All right, so we're still looking at conditional probability. We're on example 3. This time we're going to use a formula to find a conditional probability. All right, so just to recap, conditional probability formula, I've got it listed right here, okay? And reading the probability that both events A and B occur is written as probability of A and B. So that should make sense. So on the top of the formula here where you see the probability of A and B, it's exactly what it means. A and B occur. Both events occur. And then that's divided by probability of A. So conditional probability, again, two events happen under certain conditions. All right, so find the probability in example 2a using the formula for conditional probability. All right, so if you remember 2a, we did this in the last video, the probability of pass, given, defective. All right, pass, given, defective. This time we're going to use the formula. So if you remember what relative frequencies are, so we've got joint relative frequency is the ratio of a joint frequency, and the marginal relative frequency is the sum of the joint relative frequencies. So before we use the formula, let's go ahead and make a new table and quickly find the joint and marginal relative frequencies given the previous table. And then that way, using the formula, will be quick and straightforward. All right, so to fill in the table, remember we've got to do this. It's going to be a ratio, so it's going to be this number divided by the total. So how many total parts are we looking at? So if you add all of these up, 36 and 11 is 47, plus 3 is 50, 50 plus 450 is 500. So for pass and defective, we're going to have 3 out of 500, and then 36 out of 500. This one would be 450 out of 500, and this one would be 11 out of 500. So I'm going to quickly write these down. I'm going to type them so that they're easy to read, and I'm going to divide those and get those joint and marginal relative frequencies so that the formula will be easy to plug into. All right, so these would be the joint relative frequencies. And to find the marginal relative frequencies, remember, those are just going to be the total. And so the total here is always going to be a 1. And then these we just add up across the rows, and then these we add up down the columns. So 0.006 plus 0.072, that's going to be 0.078. And then 0.9 plus 0.022 is 0.922. And then the 0.006 plus 0.9, that's going to be 0.906. And then if I add 0.072 and 0.022, I get 0.094. And again, these two add up to give you this. These two down add up to give you that as well. All right, so in a previous lesson, we learned how to find these or complete these tables. And now we can use the table to quickly look at the formula. All right, so again, the formula is P of B given A. And that's going to be the probability of A and B over the probability of A. All right, so if we want the probability of A and B, okay, pass and defective, okay, the probability of A and B, 3 passed and are defective. So that's going to be our numerator. And then the probability of A. So the probability of A in this case would be the total of these together, which we found right here to be 0.078. So actually, instead of putting 3 on top, we actually could write what this is 0.006. So 0.0. And let's check this out and see what we get. So 0.006. That's the 3 that were defective out of 0.078. That's the 39 total in the defective column. And we're going to get about 7.7%. All right, if you remember in the last one, we also got 7.7%. So this is just another way to do it. This is using the formula, which may take even a little longer, but you know it's going to be accurate if all of your tables, all your numbers are correct in your table. And actually, now that I'm thinking about it, if we're just looking for one thing, we probably didn't have to complete the entire table, but it's good practice review from a previous lesson. But it would have been a little quicker if we'd only completed the first row here, which we're talking about the ones that were defective. Example 4, finding conditional probabilities. At a school, 60% of students buy a school lunch, 18% of students buy dessert, and 10% of students buy a lunch and a dessert. What is the probability that a student who buys lunch also buys dessert? So A part, we're just going to look at it first. What is the probability that a student who buys lunch also buys dessert? So this one says 60% buy lunch, 18% buy dessert, and 10% buy lunch and dessert. So the first thing we need to do is figure out what are we going to let event A and B be, because we're going to try to use the conditional probability formula. So we need to know what we're looking for. All right, so we can say event A, the first thing we need, who buys lunch? All right, so let's let probability, or event A, equals buys lunch. And event B is going to be also buys dessert. So buys dessert. All right, this might help keep the formula a little bit straight. All right, so if we're given 60%, that's the same as 0.6 if we change that to a decimal, and we're given the probability of A and B, because this one says buys lunch and dessert, so this would be A and B is 10% or 0.1. So if we look at the formula again, remember the formula is P of B given A and on top we're going to have the probability of A and B. And on the bottom we're going to have the probability of just A. All right, so the probability of A and B. So again, it says 10% of students buy a lunch and a dessert. So who buys lunch also buys dessert. That's what we're looking for. All right, so A and B buys lunch and buys dessert. So on top we can put 0.1. 10%, remember, is the same as 0.1. And then the probability of A. So again, event A is buys lunch. Again, if we look up here, it's buys lunch is 60%. That is the same as 0.6. Now we usually don't look at fractions and decimals together. So if we move both of these over one place, that's the same as, that's equivalent to 1/6. All right, so let's look and see what that is if we type this in. 1 divided by 6 is 0.16666. So that's going to be about 0.167. Or about 16.7%. So what does that tell us? Since we're looking at A part and it says what is the probability that a student buys lunch and also buys dessert, this tells us that about 16.7% of students buy both lunch and dessert. All right, so what is the probability that a student who buys dessert also buys lunch? This is B part. All right, so this is where it gets a little tricky. For A part, we did the probability of B given A, and this was our formula. We're going to change that up just a bit. As you can see, the first one said who buys lunch also buys dessert. This one says who buys dessert also buys lunch. All right, so also buys lunch is event B. So now we're going to be looking at the probability. So this is B part. So we're going to look at the probability of A given B. So it's going to change our formula just slightly, but we're still going to have the probability of A and B on top. But now we're going to have, you can see event B is buys dessert, and that's right here. So now we're going to have the probability of B on the bottom. So the order of the wording, the way things are worded is very important in these problems, and you do have to pay very close attention to the way it's worded. So now we can say that the probability of A and B, okay, buys dessert and buys lunch, that's still going to be 10%. 10% of students buy lunch and dessert. So that's going to be 0.1. And point B, or sorry, probability. The probability of B is going to be the probability of students buying dessert. So the probability of students buying dessert is 18%. So we know that that's 0.18. So we can again change this, since we don't usually use decimals and fractions together. We can change this to 10 over 18. If we want to reduce that, we can reduce that to 5 over 9. But let's see what that is equivalent to as a percent. So 5 over 9 is going to be about, oh, I typed in 59, sorry. 5 divided by 9. 0.5555. So this is going to be about 55.6%. You can see that a lot of these are rounded to the 10th place, and you will see that also when you do your assignments. So this says about 55.6% of students for the probability of A given B. All right, so the probability that students buying dessert also buy a lunch, which makes sense. You know, a lot of people buy dessert as an extra thing, but they start out with the lunch. So this shows that more than half of the students are buying dessert, but they also bought lunch, and that's conditional probability.